Dear students, welcome back to a new mathematics session. In today's session, we shall discuss the section formula in three-dimensional geometry. Let's move on to the topic. Let's begin with the section formula. The coordinates of the point R, which divides the line segment joining two points P x1 y1 z1 and Q x2 y2 z2 internally in the ratio m:n r. First of all, let's visualize the statement. So there is a line joining two points P and Q. The coordinates of P is x1 y1 z1 and the coordinates of Q, that is x2 y2 z2. And whenever R comes into the line PQ, it is dividing into two parts, that is in the ratio m:n. That means PR and RQ ratio is m:n. Here the coordinates of R we will get by using the formula mx2 plus nx1 by m plus n. That is the x coordinate. My2 plus ny1 by m plus n. That is the y coordinate. mz2 plus nz1 by m plus n. That is the z coordinate. So the coordinates we will get by using this formula. And this is in case of internal division. In case of external division means the point R will be somewhere outside of this line PQ. So if the point R divides PQ externally in the ratio m:n, then its coordinates are obtained by replacing n by minus n. So the coordinates will be replaced. Here you can see plus is there. Here also plus is there. Plus n. So that plus n is replaced with a minus n. So the coordinates of R. Here also coordinates of R we are going to calculate by using the formula mx2 minus nx1. The previous one, that is plus, here it comes as minus. So mx2 minus nx1 by m minus n. Here my2 minus ny1 by m minus 1. Then mz2 minus nz1 by m minus n. The first one is internal division and the next one is external division. Then the coordinates of the midpoint of the line segment joining two points P x1 y1 z1 and Q x2 y2 z2 are. Midpoint means we know now the point R is dividing PQ in the ratio m:n. But when R is in the midpoint between P and Q means the ratio m and n will be same. m:n will be 1 by 1. That means 1:1. Equal division. So equal division means m also 1, n also 1. So here the coordinates will be getting m and n we can put as 1. That is the way we have to calculate. That is x1 plus x2 divided by 2. M and n becomes equal division. Means here also 1, here also 1. 1 into x2 is x2. 1 into x1 is x1 by 1 plus 1, that is 2. So x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. This is what the midpoint formula. Then the coordinates of the centroid of a triangle whose vertices are x1 y1 z1, x2 y2 z2 and x3 y3 z3 are. Even in class 10 we have learned this one in coordinate geometry. There of course we use two coordinates, but here in three dimension we will use three coordinates. The same thing, only the expansion up to z. That is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3 and z1 plus z2 plus z3 by 3. That is the coordinates of the centroid of the triangle. Next we shall discuss the exercise questions. First question from exercise 12.3. Find the coordinates of the point which divides the line segment joining the points -2, 3, 5 and 1, -4, 6 are in the ratio 2:3 internally. So here it is an internal division. So let's take the point. First point as A and the second point as B. Then the coordinates of the point P we can assume as x, y, z. There is a point P in between A and B. The coordinates of P only we want to calculate. That let's take it as x, y, z. Then next we will visualize this one by using a straight line. First point A we have taken, second point B we have taken, and there is a point P. It is x, y, z coordinates and it is dividing the line segment AB in the ratio 2:3. So we have to calculate this x, y and z. So we know the section formula, that is x will be getting the form by using the formula mx2 plus nx1 by m plus n. So this is m, this is n. So okay, let's say let's write these things here, that will be easy. So this one we can mark it as m, and this one we can mark it as n. This all x1 y1 z1, this is the first point. We x1 y1 z1, x1 y1 and z1, and the next is here we can take it as x2 y2 z2, x2 y2 z2. So for the first question we can do this one, then later on this mentally we can do. So this, use this formula. So xyz is equal to mx2. mx2 means here m means 2 into 1, it's written 2 into 1 plus nx1. nx1 means here this way 3 into minus 2 divided by m plus n, 2 plus 3. Denominator is same everywhere, m plus n. Okay. The next is my2. From here we have to start my2, that is 2 into minus 4, that is written, plus ny1, that is 3 into 3, that's here, divided by m plus n. Then next is 2 into 6, this way 2 into 6 plus 3 into 5, it's written, divided by m plus n. That is equal to 2 minus 6 divided by 2 plus 3 is 5. Here it is 2 into minus 4 is minus 8 plus 9. Minus 8 plus 9 divided by 5. Then 2 into 6 12. 12 plus 15 divided by 5. That is 2 minus 6 is minus 4. So minus 4 divided by 5. Here minus 8 plus 9 is 1. So 1 by 5. Next 12 plus 5 is 15 is 27 divided by 5. So we have got the 3 coordinates. Then thus the required coordinate of the point P is minus 4 by 5, 1 by 5, 27 by 5. So always it is better if you use this type of a diagram and then write. There will be not much more steps. The first question, second part. Find the coordinates of the point which divides the line segment joining the points minus 2, 3, 5, 1, minus 4, 6 in the ratio 2:3 externally. This is external division. As before, A we have taken, B also we have taken, then we will assume the coordinate P as x comma y comma z. Then visualize. So here the external division means the P will be somewhere outside of the line segment AB. So P we are taking here. So the coordinates of A is there, coordinates of B is there, and the external division 2:3. So this portion we have taken 2 and this one we have taken as 3. Now as before, one is m, another one is n. Okay, we will write that also. One is m we can take and this one is n we can take. This one we can take it as x1 y1 z1, x1 y1 and z1, and when we take here this is x2 y2 z2. Then we can use the formula, external division formula. You know that there is a negative sign, mx2 minus nx1 by m minus n. Same thing is there for y and z coordinates. So xyz we will calculate, that is equal to mx2. mx2 means here 2 into 1, 2 into 1 minus 3 into minus 2, it's written, divided by m minus n, that is 2 minus 3. Next is 2 into minus 4 minus 3 into 3, that is written. Then again from here only we are starting this way, cross. Okay, 2 into 6 minus 3 into 5, minus 3 into 5 divided by 2 minus 3. Then calculation, 2 into 1 is 2, minus into minus plus, 3 into 2 is 6. Then 2 into 4 is 8, that is minus 8. Then minus 3 into 3 is 9. Then 2 into 6 is 12, minus 5 into 3 is 15. Denominator all 2 minus 3, that is minus 1. So 2 plus 6 is 8, 8 by minus 1. Then minus 8 minus 9, that is 17, minus 17 by minus 1. 12 minus 15, 12 minus 15 is minus 3, minus 3 by minus 1. Do little more work. 8 by minus 1, that is minus 8. Here both minus cancelled, only 17. Here also both minus cancelled, that is 3 by 1 is 3. So this is the required coordinate. Next we shall discuss the second question. Given that P 32 minus 4, Q 54 minus 6 and R 98 minus 10 are collinear, find the ratio in which Q divides PR. So here they are collinear. Collinear means what? These 3 points are collinear, means these 3 points lie on a same straight line, and P, Q and R, there are 3 points, and find the ratio in which Q divides PR. Okay, so this Q is dividing the line joining P and R in a particular ratio. That ratio we have to find out. So let's take the given conditions. There are points are given to us, and out of that Q we are taking. That Q is 5, 4, minus 6. divide the line segment PR, that means P32 minus 4 and R98 minus 10 in the ratio K:1. This is the required ratio. Okay, so let's visualize. Q is here and Q is dividing the line joining PB in the ratio K:1. We have to find out the value of K. Okay, so by using the section formula, this is a section formula, and here x, y, z is there with us. The coordinates of Q is there with us, and we will be equating this value with the given finding out values. We will equate and find out the value of K. Okay, this type of question in two-dimensional geometry we have solved. The same thing only here also. Let's take the first point P as x1, y1, z1, and coordinates of B as x2, y2, z2, and this one is x, y, z. Okay, now by using the section formula, this 5, 4 minus 6, this x, y, z value we know. So just 5, 4 minus 6 is equal to mx2. You can see we will start from here. Mx2, that means k into 9. This is the way always we start. Okay, 9 into k, that is 9k, plus 1 into 3, that is 3, divided by m plus n, that is k plus 1. Next is again k into 8, that is 8k, plus 1 into 2, that is 2, divided by k plus 1. Next is k into minus 10, that is minus 10k, then 1 into minus 4, that is minus 4 by k plus 1. Now ordered triplets are equal, means the corresponding coordinates will be equal. First one will be equal to the first portion here, that means x coordinates. 5 is equal to 9k plus 3 by k plus 1, cross multiply it. 5 into k plus 1 is equal to 9k plus 3. Then when we remove the bracket, 5k plus 5 into 1 is 5 equal to 9k plus 3. So 5 into k is 5k. Bring this 9k to the left side, that comes as minus 9k. And here one 5 is there, that we can bring to the right side, that is 3 minus 5. 5k minus 9k is minus 4k equal to 3 minus 5, that is equal to minus 2. Then from here k is equal to 2 by minus 4. 2 by minus 4 means minus minus cancelled. 2 and 4 when we cancel, 1 by 2 will be coming. So this is k:1. Actually this one we can write it as k by 1. Okay, k by 1 is 1 by 2. That means k:1 is 1:2. So the ratio we have got, that is the point Q divides PR in the ratio 1:2. Next we shall discuss the third question. Find the ratio in which YZ plane divides the line segment formed by joining the points -2, 4, 7 and 3, -5, 8. Find the ratio in which the YZ plane divides the line segment formed by joining the points -2, 4, 7 and 3, -5, 8. Here it is dividing. Find the ratio in which the YZ plane is dividing the line segment. Previously we have calculated a particular point is dividing. Now here the plane YZ plane is dividing the line joining these 2 points. So here let AB be the line segment. We can assume here there is no letters are available, so let's take it as A and B. Then YZ plane divides the line AB at PXYZ in the ratio k:1. This is our assumption, that YZ plane. So here you can see this point P means there is a plane comes this way. Okay, there is a plane is passing through this one, that is our YZ plane. YZ plane means you must know the coordinates of YZ plane. YZ plane means there is no x here, that means x coordinate will be 0. So 0 YZ, that is the coordinates written here. Since this point is from YZ plane, x coordinate will be 0 because there is no x axis is having connection with this one. So y and z coordinate will be there, x coordinate will be 0. So 0 YZ. The rest of the things are same. A and we know, B we know, and the ratio which is dividing, that is k:1. The same process only here the difference is we have to find out or we have to assume this coordinate. Previous case directly we can take x, y, z, but here since it is from YZ plane, we have to write the coordinates correctly. That's the way we have to do. Now this is a section formula. By using the section formula, instead of x, y, z we are having 0 YZ. Okay, the rest of the things are same. So 0 YZ is equal to k into 3. This is the way always we start multiplication. K into 3, that is 3k. Then 1 into -2, that is -2 by m plus n, that is k plus 1. Then second, k into minus 5, that is minus 5k. Then 1 into 4, that is 4 plus 4 divided by k plus 1. Then next is k into 8, that is 8k, plus 1 into 7, that is 7 by k plus 1. Now you see, as before, the ordered triplets are equal. That means the corresponding elements will be equal. This is x coordinate, this is y coordinate. Sorry, x coordinate. Corresponding x coordinates will be equal. That means 0 is equal to 3k minus 2 by k plus 1. Cross multiply it. K plus 1 into 0 is equal to 3k minus 2. That means 3k minus 2 is equal to 0. Then reverse it. Then from here k will get this minus 2 coming to the right side. It comes as plus 2. K is equal to 2 by 3. That means k by 1 is equal to 2 by 3. That is k is to 1 is equal to 2 is to 3. So the required ratio is 2 is to 3. Next we shall discuss the fourth question. Using section formula, show that the points A 2 minus 3 4, B minus 1 2 1 and C 0 1 by 3 2 are collinear. Here we are asked to use the section formula to show the points are collinear. Previous exercise we have done by using the distance formula. There AB distance we will calculate, BC distance we will calculate, then AB plus BC we will prove that it is equal to AC. That is the way distance formula using and calculating or showing that points are collinear. Here we are using section formula. This is also simple only. Let's take this A, B and C points, and how do we prove? A, B and C are collinear means the point C divides AB in some ratio externally or internally. One point C will take, the C must divide A and B in a particular ratio. It can be internal or it can be external. That is not an issue. If the ratio exists, then we can say that the points are collinear. So let's represent it in a line. A, B we have marked. C, here considering the internal division, that is in between A and B we are keeping C, and it is in the ratio k is to 1. So by using the, okay, let's assume this one. Let the point C 0 1 by 3 2 divide the points A 2 minus 3 4, B minus 1 2 1 in the ratio k is to 1. We have already discussed this one. The same thing we have to write. That's all. Then this is x comma y comma z. By using section formula, k into, this is the way always we start, k into minus 1, that is minus k, plus 1 into 2, that is 2 divided by k plus 1. Next there is a problem here with the sign. K into minus 1, sorry, k into 2, second value only we have to take, k into 2, that is 2k, plus 1 into minus 3. Of course here there is minus sign is there. We have marked here mistake, that is plus is marked. So this portion we can mark it as minus. Okay. Then once again k into 2, that is 2k. Then 1 into minus 3, that is minus 3 by k plus 1. Next is k into 1, that is k, plus 1 into 4, that is 4 by k plus 1. Now the coordinates are ready. These, ordered triplets are ready now. So these triplets are equal means their corresponding coordinates will be equal. So the first one is 0. Here it is this one. So these two we can equate. 0 is equal to minus k plus 2 by k plus 1. When you cross multiply, minus k plus 2 is equal to 0 into k plus 1, that is equal to 0. So minus k is equal to, take this plus 2 to the right side, it comes as minus 2. So k is equal to 2 will become. That means k is to 1 is 2 is to 1. K divided by 1. Here there is no denominator, so we can keep 1. K divided by 1 is 2 by 1. So the ratio is 2 is to 1. So we can say, hence the point C, we have already taken C in between A and B, and we have concluded that the point C is dividing the line segment AB in the ratio 2 is to 1. So since the ratio is existing here, we can say that these 3 points are collinear. Next we shall discuss the fifth question. Find the coordinates of the point which trisect the line segment joining the points P 4 2 minus 6 and Q 10 minus 6 6. Trisect means 3 equal divisions. Okay, bisect means 2 equal divisions. Here trisection is studied. So point A comma B comma C and point B P comma Q comma R trisects the line PQ. Okay, let's visualize it. There are 2 points are given, P and Q. So we have taken P and Q and both the ends of a line segment. The 4 2 minus 6 is P coordinates and Q is this one. And if you want to divide it into 3 pieces, then there should be 2 points in between P and Q. Then only 3 portions we will get. Okay, so that's why 2 points we have taken. One is A, another one is B. Okay, remember that because it is a trisection. Trisection means 3 portions. There is a line segment AB, in between there is only 1 point, means we will get 2 portions. So we want 3 portions here, so that's why 2 points we have taken, A, ABC, B, PQR. And since it is trisection, 3 equal divisions. So AP will be equal to AQ will be equal to BQ. That means 1:1:1 ratio. Then first of all, point A divides PQ in the ratio 1:2. We can't take all these things together. Let's take the first portion PQ and this point A. And if you take that point, we will be coming like this. Means B we are not considering first. We are taking P, A and Q only. So P we know 4, 2, minus 6. A is ABC and PA is 1. Next is AQ is together 1 and 1 together, it is 2. So 2:1. Now we can say A is dividing the line joining PQ in the ratio 1:2. Okay. So by using the section formula, we are going to calculate the coordinates of ABC. ABC is, you can see there 1 into 10, that is 10, plus 2 into 4, that is 8, divided by 1 plus 2. 1 plus 2 is 3. Next is 1 into minus 16, that is minus 16. Then 2 into 2, that is plus 4 by 3. Next is 1 into 6, that is 6, minus 2 into 6, that is 12 by 2 plus 1 is 3. That means ABC will be equal to 10 plus 8 is 18 by 3, that is 6. Minus 16 plus 4 is minus 12 by 3 is minus 4. 6 minus 12 is minus 6 by 3 is minus 2. So ABC we have got. Now point B PQR, this is the point B PQR divides AQ in 1:1. You can see here now coordinates of A we are having, we have calculated. Now you can see these 2 points, when we consider the point B is the midpoint because the ratio is 1:1. Now we have excluded this point P. We are taking only these 3. So when we visualize, we are taking A, B and Q. P we are not taking. Okay. So it is in the ratio 1:1. That means the midpoint. Coordinates of B is x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. Because A and Q we are considering the time, the ratio is 1:1. That means equal division. That means B is the midpoint. We can use the midpoint formula. The coordinates of B easily we can calculate. That is equal to 6 plus 10 by 2. Then next is minus 4 minus 16 by 2. Minus 2 plus 6 by 2, that is 6 plus 10 is 16 by 2, that is 8. Minus 4 minus 16 is minus 20 by 2, that is minus 10. Minus 2 plus 6 is 4 by 2, that is equal to 2. So the coordinates of B we have got as minus 8, minus 10 and 2. Hence the coordinates of A is, we have calculated, that is 6 minus 4 2, and coordinates of B is 8 minus 10 and 2. Dear students, today we have discussed the section formula and we have solved problems from exercise 12.3. So we have completed the chapter 3-dimensional geometry, and I request all the students to go through the entire portions, first exercise, second and third exercise, and if you have any doubt, please mark it and keep. We will discuss it during the discussion session. Thank you for watching.